Okay, so hello everyone. My name's Lavanya, and I'm studying for the DAT currently, the Canadian one. And so one of the things I decided is I will just make some videos for myself and maybe help out some other people on some of the biology content currently, because that's what I'm focusing on, because there's so much to cover in biology, I feel like. And I do want to get the general scope of things so I can understand it better. So we're going to start right from the basics, and that's the properties of water. So I'm just going to outline that quickly. Properties of water. So we can have that water is an excellent solvent. So it'll dissolve things pretty easily due to it having the high dipole moment. And it can break ionic molecules and helps easily dissolve molecules, basically. And then we also have high heat capacity. This also explains water's heat of vaporization, and basically a large amount of energy is needed to change the temperature of water. So, for example, you have a giant lake and it's really hot and sunny, but the temperature of the water will remain relatively stable. Next would be ice floats. So in this case, because solid is much in water's case only, the solid form is much less dense than ice because the hydrogen forms a crystalline, like the hydrogen bonds are as far away as possible, and the crystalline structure becomes more rigid and it becomes less dense, so ice floats. This is different than other like normal properties of different molecules or atoms. And so in this case, ice floats unlike other things, and this can be seen through the graphs. So if I was to draw the normal graph with pressure and temperature, so this is going to be what it looks like normal, the phase graphs here. As you see, when you raise the temperature and pressure, it'll go to a liquid. It'll continue going to a solid basically, because you raise the temperature, raise the pressure, it'll become more of a solid. And then for water, this is how the phase change graphs look. Because as you raise the temperature and the pressure, you're going to end up being in a liquid form. And this just shows and proves the ice floats property again. Okay, so let's continue on. We have cohesion slash surface tension. This property basically represents the fact how like water bugs can almost float on ice, basically. Like, I don't know, let's say this is a bug and it's on water. It will stay on the top of the water because of surface tension and adhesive properties. Cohesive properties. So this is because water is attracted to like substances, and thus it allows water bugs to float, for example, again. Next, we have adhesion. So even though water is attracted to like substances, it is also attracted to unlike substances. So in this case, adhesion allows for water to get attracted to unlike substances, which is the basis of capillary action when water flows up in the plant to the leaves from the roots. Capillary action actually encases both cohesion and adhesion, so it requires both of them, but I would refer it more to adhesion in this case. Let's continue on with functional groups. So some of the key functional groups you need to know for the DAT. There's the hydroxyl functional group, OH, which is polar and hydrophilic. And then we also have carboxyl functional group, COOH, which would look like this basically. And this one is a weak acid along with being polar and hydrophilic as well. And then we have NH2, which is a weak base, and it's also polar and hydrophilic. PO4 3 negative, so phosphate. It is an acid, and it is also polar and hydrophilic. And finally, carbonyl. So that is polar and hydrophilic. Lastly, we have CH3, which is nonpolar and hydrophobic. Okay. Let's continue on to the first macromolecule section. Actually, I will save this one for the next video because I'll just go through each one by themselves so I can find it later. Anyways, I was a little nervous recording this, you could probably tell, but yeah. Whoa, okay.